In this video, I'm going to show you the most efficient way to create the tool paths for your vacuum table. In particular, we're going to accomplish this by one, using the same size bit for this and this and this, which is a 1/4 inch downcut bit that will keep the melamine from splintering when you try to machine it. Number two, we need the grid that we create to be one continuous vector. I'm going to show you in this video how to do that very efficiently. That skill of creating a single vector for a grid is really nice, because if you ever want to put a gridded pattern on a spoil board with a VCarve bit for measurement purposes, this is going to be very transferable. So even if you're not going to make a vacuum table, you probably want to see at least this grid portion. It's a great little skill to have. Then this air channel, we're going to create a raster structure such that the grid lines are going to be aligned with the longest path here. That will increase the speed, and this is going to be a profile inside cut with tabs on the sides so that this doesn't go flying out. Or if you don't want to do cleanup of those tabs afterwards, then you can always pocket cut this whole thing out. I'm going to show you how to create efficient tool paths for your vacuum table. The first thing you want to do is set up your job size. I would recommend you use whatever the dimensions are on your particular spoil board of your CNC, so your max cutting area. And then your thickness is going to be the thickness of the melamine board that we're going to be cutting this vacuum table fixture into. I would zero off the surface, set my XY datum on the bottom left-hand corner, and click OK. We're going to go up to the grid snapping on the top of Vcarve. If it's not already on, click on it. If you click F4, it'll bring up the snapping tools. Make sure you have snap to grid on, and you want to put the spacing as 25.4 millimeters. That will give you 1 inch wide dots all across here, because there's 25.4 millimeters per 1 inch. Go ahead and click OK. Then we're going to go over under create vectors, go to the second vector down, which is the draw polyline tool. Left click on it. Go down to your 0, 0. I'm just scrolling in with my mouse wheel so you can more easily see, and we're going to create a grid. So I'm left clicking and I'm just hovering over those dots, and I'm just going to wind around through the dots. Now let's say you accidentally click on the wrong spot. How do you get rid of it? You just come over here to the left hand side and click undo, and it will back up one dot, and then you can continue on. So we're going to weave. See there, you notice that right there I had a curved line. It's because I held my mouse when I was dragging. So I'm going to click undo, and I'm going to fix that. So be careful that you're not moving your mouse when you're doing your clicks here. And relatively quickly, oops, I did it again, so I'm going to click undo. Slow down when you're doing a video, and you'll probably speed the video up. And that looks like it. Oops. I need to be more careful. Okay, and now I'm going to come across. It's nice if your last point ends up diagonal from your starting point, because you're probably going to end up terminating this in the easiest spot. You're either going to end up with one vector or two when we get all done. This one we left out because when we come down, it's going to terminate, and when you click on the original starting point, it'll end the vector, and there we got a grid. This particular one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a 10 by 10 grid that we created. Why did we do it this way? Well, actually, let me show you one more thing before I do that. Let's say you were doing this, and let me just make another one of these really fast. And you were doing one of these polylines. Oops. You're doing one of these polylines, and you end up with a scenario where you want to end it somewhere else besides that starting point. You can do that by hitting the space button of your keyboard, and that will terminate a polyline. Another thing that happens is, say you came over here and you ended it prematurely, then you can just create another polyline and finish out your structure. So hope that helps. I'm going to get out of here. I'm going to get rid of this one. I'm going to name this layer, and instead of calling it layer 1, I'm going to call it grid 10 by 10. I'm going to hit enter. I'm going to do another layer. I'm going to call it air channel. I'm going to add another layer, and I'm going to call it sprinkler hole. I'm going to hit enter, and I'm going to left click and hit another layer. I'm going to call it master layer. Hit enter to make sure the name takes. The grid layer is set. Let me just show you really quickly what happens if I go in the node editing mode and I click on this. There's only one green dot, which means there's only one path through this whole grid, which means it's going to machine super fast. We'll get to that in a second when we set up our master layer, but I'm going to go ahead and turn this off for a second. and I'm going to set up our air channel. And so make sure the left channel, the air channel is selected. You've got it on. We're going to set up a rectangle. We're still going to put it down here on the bottom. We'll eventually shift these all around in the master layer, but it's nice if the anchor points are all at the 0, 0. And that way, if you want to save them as separate machine paths for individual points, it's easy to do. The width of our rectangle, we want to be 20 millimeters wide. The length is determined by the distance from the edge of your spoil board to the edge of your CNC. And then I would add 5 more inches. Mine was 5 inches from the edge of my spoil board to the edge of my CNC bed. And then I wanted to go out 5 more inches so I could easily fit on my vacuum. So that's a total of 10 inches, and 10 times 25.4 gives me 254. I hit create, and there's my air channel that we're going to have to pocket out. Turn that layer off. I'm going to left click on the sprinkler hole and make sure that it's the active layer. I'm going to go up here to draw a circle. I want the center point to be at 0, 0. If it's not, go ahead and change that. Click on diameter, and we want a diameter of 43.75 millimeters, which is 1.7224 inches. And I'm going to create it. And there's my sprinkler hole. And now we're going to transfer all of these over to our master layer. So let's go ahead and close this. I'm going to click on this. I'm going to drag on this sprinkler. I'm going to right click. I'm going to go copy, not move, but copy to master layer. And we should have on our master layer now, if I click on it, sure enough, there's our sprinkler head. I'm just going to go ahead and grab that by left clicking it on our master layer, and I'm going to get out of the way. Then I'm going to go and shift our grid layer. I'm going to click on that grid, left click, copy to layer. I'm going to bring it over to the master layer again. I'm going to turn off the grid layer, and I'm going to go look at my master layer again, and there's my grid. And I'm going to scroll out with my mouse wheel. I'm going to left click, and I'm just going to drag it up in here so that it's easy to see what's going on. And now we need to go get our air channel. So I'm going to click on the air channel, make that active by left clicking on it. I'm going to grab that. I'm going to left click. I'm going to copy to layer, master layer. I'm going to turn off the air channel. I'm going to turn on my master layer, left click it so that it is the active one. And now we have all our parts here. Because I know this is a whole machinable bed, I can go ahead and arrange these however I like. If I wanted a standard vacuum table with the sprinkler through the middle of the grid, I could just drag it out here and of course shift my grid down, but that's not quite what I want. I would really like this to be something like this, where I have this lined up like so. Now, if you want to micro adjust, if you hit Control with it selected and arrow key, you can line these things up. And if I zoom in with my scroll wheel, we want to make sure that that top of that grid overlaps the air channel, and that overlaps right here. So that looks pretty good. If I left click on my circle and click again and use holding down the Control key and my arrow, I can shift this over. And there's some leeway in the path length, and I can just line that up as best I can. As long as that's overlapping that channel, I should be good to go. And now we've got it lined up. Let's go set up our tool paths. So this is the area that we're going to machine on our piece of melamine. And in fact, if you don't want to waste quite as much board, you can scoot this down just a little bit more, something like that. But let's go get this one machined. I'm going to click on it. I'm going to do a profile. I'm going to do 4 millimeters depth. I'm going to select a 1/4 inch end mill, which is 6.35 millimeters. My pass depth, I'm going to do 2 millimeters. I'm going to, here's my particular machine. You're going to use it for whatever is appropriate for your machine. I'm going to hit select. And when we do it, we want to do a line on for our grid. And since it was a 10 by 10 grid, we're going to call this grid 10 by 10. Depth of cut is 4 millimeters. And this is a 1/4 bit. Calculate. And let me just show you really fast why we did it, what we did it. So if I slow this down just a bit and I do preview visible tool paths, you can see that on this, my bit it's not going up and down with my Z. It's doing one continuous pass, and the first one, it's cutting out 2 millimeters depth, and then it's going to trace back over this and get the second 2 millimeters of this, and it's super efficient because it's not moving the Z axis up and down. It gets very smooth cuts, and we've machined that. If I want to look at how long that took to machine that grid, if I click on this, I'll close this for a second. If I come over here, it says 9 minutes and 42 seconds, but it's scaled by a factor of 2. There was only one up, down, Z movement. So I probably don't even need a scale factor on this. Divide that by 2, you're under 5 minutes to machine the grid, which is one of the longest parts of this whole CNC process. The next thing we need to do is we're going to go back over here, get in the 2D view. Let's shut off the grid toolpath. Let's click on the rectangle that we created, which is our air channel. We're going to go over here. We're going to do a pocket toolpath. We're going to do it the same depth as we did our grid, which is 4 millimeters. We're going to make sure that we have a pass depth of 2. And we do this. I'm going to click on this. I want to do a raster toolpath with that 1/4 inch bit. We can do conventional, that is fine. The cut direction for the raster, we want to set it at 90, and by doing 90, it will do it so that our lines, when it cuts, are vertical instead of little short paths. If we did 0, it'd be a whole bunch of little short paths, and that would be very slow to machine. And we're going to come down here, and we're going to call this air channel. Depth of cut, 4 millimeters. And we're going to call this 1/4 bit. Calculate. And there's our paths. Turn that off. We go over here to the 2D view, click on our hole for our sprinkler. We're going to go to tool paths. And we can do one of two things. If you want, you could do a pocket tool path for the full depth of this melamine board, and you wouldn't have to do any cleanup, but it would generate a lot of sawdust. If you do it that way, it'll take a little longer to machine, but there's no cleanup of tabs, or the fastest way to machine is to do a profile. And the depth of cut is going to be the board thickness, which is Z for a shortcut on this, plus I like to do 0.1 millimeters beyond that. Hit equals, there's our cut, and we're still using the same bit. It's going to do it in 9 passes, but we want the machine vectors. It's critical that you do inside and to the left if you're doing a profile cut. I do recommend a separate last pass of 0.5 millimeters. You might be able to get away without tabs if you use that depth by having just a tiny bit of depth as an onion skin on the bottom. But to be safe, I would recommend go ahead and put some tabs in there, maybe 1 millimeter in thickness and maybe 4 millimeters long. I'm going to edit my tabs, and if I zoom in with my mouse scroll wheel, put a couple tabs in here like so, and then of course when you get all done, you'll have to clean those up. And we're going to call this sprinkler hole. Depth of cut 16.48 millimeters, 1/4 bit. Calculate. It does say I cut through 1/10 of a millimeter, so it will cut a little tiny ridge in my spoil board. And now finally, let's see all of these machined in one continuous path. So coming down here at the bottom, get all of them selected, reset preview. Preview visible tool paths. And so if this is my board here, it's going to start by machining out my grid pattern, and it's going to do it in a couple of passes. And you'll see that it's very quick to machine. If you have a stronger machine, you could probably do that in 1 4 mil pass. And then we're going to machine out our channel for our air, and that requires a couple passes to get our 4 mil depth of cut. So we're seeing that here. And then finally, we're going to do our profile pass that is going to cut out our hole for a sprinkler. And when you clean this up, you will obviously cut those tabs and sand them smooth so that our sprinkler will fit in there. And there you have your first vacuum table. Let's take a quick glance before we leave this behind and see the length of time it would take to machine all these. So if I go and click this and this and this and click on it, you can see it says 20 minutes, but it's a factor of 2. We only had 1, 2, 3 up-down movements of this. So that scale factor is way over exaggerated. It would probably machine in 10 minutes or so in real time. And if you want that grid pattern and even this air channel, probably you could get away with doing it in 1 pass versus 2 if you like. We need to, of course, save these. When you go to save them, because we use the same bit, we can go ahead and select all our tool paths, all 3 of them, and save visible tool paths to one file, save the code, and it will machine these all in one fell swoop. I would recommend when you machine these, of course, because it's melamine, you don't want to breathe that dust, have a dust mask on, have, of course, safety glasses on. If you have a dust boot, I would highly recommend put your dust boot on when you machine this out. This length, remember, is going to be the length from your spoil board to the edge of your CNC bed plus 5 more inches, and that'll give you plenty of room to hook that vacuum up. As a side note, for those with smaller machine beds, don't feel like you have to machine this all in one fell swoop. If you have a big machine, then you're going to, of course, save all these tool paths as a single job and just run it all at once. But if you have a small machine bed, go ahead and just machine this portion and then remount your piece of melamine and then machine this portion, making sure that you re-zero your y-axis so that when you cut this grid, it crosses over that air channel and you'll be good to go. And then, of course, that allows you this to protrude off the end of your CNC bed. If you haven't seen my last video, go ahead and watch that and you'll understand. We have our table set up, the vacuum table that I'm going to show you how to optimize the machine paths for. And I just want to talk about a major addition that I did. I added a side air hole to my side of my pool noodle that allows air to get down in your vacuum and help cool it off. And even with that air hole, which of course is going to diminish or pull your vacuum a little bit, it will still have plenty of suction to pull down a board flat for the purposes of V-carving. So I strongly urge you to do that. Otherwise you could overheat your vacuum, and this will help alleviate that. Still monitor your vacuum temperature, otherwise you could potentially burn out the motor. And so we're going to go ahead and we're going to slip this on here like so. And I'm going to have a board that's bowed so you can see it pull the bow out. Okay, and let me turn it so that the bow is maximized. There's over 1/8 of an inch rise in the center of this board right here, which would be a disaster to V-carve. And then we need to seal off this channel. You could do it with strapping tape, but honestly, the easiest way to do something like this is just put another flat board on there. Don't put it over your screw or you're not going to get a flat seal. And of course you would only need it as wide as this to seal it off, but I'm going to set it on here. It'll pull down here, not super strong because we don't have a lot of vacuum chambers here, but once that air gets out in here, this board is going to be anchored extremely strongly, and that of course is the one that actually gets machined. So let me go ahead and put this back on here. Turn on my vacuum. Like so. Hold this board up. Got to press down to get the initial vacuum seal. And once it grabs, super strong, and yet we got a lot of air going through the side of this pool noodle, keeping our vacuum cooled off. If you think you need more, you'll have to adjust that, but that will help a lot keeping your vacuum temperature down. Before I give you my last hack, if you could hit like and subscribe if you found things in this video that you found intriguing, I would really appreciate it. I'm a very small channel, makes all the difference in the world. For the benefit of those that didn't watch my last video, I'm gonna give you a 15-second recap. You need an orbital sprinkler head for this build, you need a pool noodle, and you need a piece of melamine shelving or a melamine board. You can make it for under 20 bucks. And here's my last hack. If you want to add more friction to your surface, then buy yourself some contact beaded grip drawer liner. I got this at the hobby store, 5 feet by 18 inches, and it only cost me $6. Cut off a square, put it over your grid, and it should anchor it down really nicely. I would cut it just inside the borders of your square. Super cheap, and it's disposable if you want to get rid of it. It'll also keep you from cutting through, if you cut through your board, not cutting into your spoil board. If you like this video, I think you're gonna really like this one.